Hello, my name is Jesse Chotiner, and I'm doing a tutorial for the 2D wind tunnel simulation for Project 1 for Fundamentals of Aerodynamics in Spring 2026. I will be doing my wind tunnel design first in a separate CADing software, and then I will go through the rest of the meshing and setup and solution. So first we have our fluid flow fluent set up here next to the one I've already done. And we're going to go into Inventor, which is the CAD I've decided to use. We're going to go into Part File, and we're going to sketch out our wind tunnel. So to do this, I'm going to do a little bit of just some designing. So first I'm going to do an 11-inch here because the wind tunnel is 22 inches, and we're going to just mirror this along the line in the center. And then we have a 15-inch thing there for the settling chamber, and then our contraction chamber is 24. So we're going to do a little construction line there. And we're going to come down from the construction line and we're going to go to the midpoint of our center. And this is 6 inches. 6 divided by 2 is 3. We're going to climb that up there, and that is our contraction chamber of 24 inches. And then we're going to go here to our test section, which is going to be 12 inches flat. And now we have the diffuser. So the diffuser is 42-inch length with a half diffuser angle of 3 degrees. So what we're going to do is we're just going to do a big thing here that's going super far beyond our 42 degrees. And we're going to make it 3 degrees from this line here, and that gives us our diffuser out, or our wall, I suppose. And then what we're going to do is we're going to take a little construction line here, and we're going to take it at the end here, and we're going to just do this along this line at 42 inches. So we can see that is where our point is going to stop, and we are going to come up like this. And if we do a little trimming, we can take these lines, delete them. We don't need that, we don't need that. We can see it's 42 inches, and that looks very nice. So we have our setup here, which looks very good, and we're going to just mirror it to get the full scale of the entire thing. But before we do that, I need to make a center line to mirror it around. So we will actually, before I do that, we're going to enclose this because this needs to be an enclosed surface. So we're actually going to just delete that. So this just stays one line going down. That will make it easier for us later on. And now we will finally take this, take everything, mirror it, apply, and done. We're going to get rid of these dimensions here because we don't need them. But as you can see, we have 11 inches here. We have 15 inches here. And by 11, actually, I mean 22. And we can see that this is 24. We can see that this is 12. We can see that this is 6. And this is 42. And this is over constraining it because I don't know what I'm doing there, but this is 3 angles. So we're going to take all these away, and something I'm going to do is just going to center this between everything. So it's 93 inches total. So what we're going to do is we're just going to see, so this to here is like that. So we're just going to move this entire thing from a base point here to right there. And we will take the whole thing again, base point here, and hold on. We're going to make a little construction line here just to make this easy, and we're going to go out 93 divided by 2, which is 46.5. So we're going to take this entire thing, and we're going to move it based off of that point, and that's okay. That's not okay. We just got to delete these dimensions. We're going to move this base point here, put it all the way over here, and lovely. So now our entire wind tunnel is measured correctly, and we are in the exact middle of the graph. So when we do it later, we'll know where to set up our center line. So we're going to finish that, and to create a surface, we got to do patch. And yes, we need to do patch. We're going to click this. Click OK, and now we have our little wind tunnel surface. We're going to save this, in our document, we're going to do when. We'll just do, it's the same thing as this one, so we're just going to name it 2.0 and save it. So now we have that. We're also going to export it as a step file. So that is what we will import it into Ansys as. So we'll do step. And as you can see, there's the previous one. And we're going to save right there. And that should be good to go. Let's move on to the meshing. All right, so we're back in Ansys, and what we're going to do is we're going to take our geometry and we're going to import it from what we just did. And we're going to do our little step file here. And that's it. We're going to leave it like that. We don't need to open this again. And now we're going to open the mesh and create the mesh. All right, so we've opened the mesh tool, and we're just going to create a very simple mesh. We're not going to try and over-define it. So we're going to go to update first, and we're just going to create one right off the rip, and we can see these cells are way too big. So we're going to go to mesh, we're going to go to insert, and we're going to go to method. We're going to click the entire geometry, and we're going to do triangles. And we're going to click generate really quick to see what we get, and as you can see, it will now all be triangles, but they're still pretty big. So we're going to take our element size, and we're going to do it to 1e -2. Not too sure why I did that. It should be fine. It's just 0.01 meters, which is about 10 millimeters. So if we generate this again, we'll get a much finer mesh. Not too fine, but enough to get the job done. And we are going to, let's generate again just because I want to make sure it's good. And this will be our mesh. And that's it for the meshing. We could make it finer to get better details, but we don't need to do that as of now. So now we're going to go into the setup and solve it. Alright, so the mesh has been updated, and we're going to go into the solution tab, and we are going to solve our 2D wind tunnel simulation. Alright, now that's loaded, we're going to go into models first, and we're going to go to viscous, and we're going to change it to laminar as the project says to simulate it in viscous laminar settings. So we're just going to do that. Everything else is okay for now. Materials, we're going to check air. The properties are okay. Solid, aluminum, that's okay. Cell boundaries, fluids, that is okay. Next thing we're going to do is go into boundary conditions, and this is very important. I realized I forgot to name the surfaces in the mesh, so we're going to go back to the mesh. Okay, so we're back in the mesh, apologies for that, and we're going to do some name surfaces here. So we're just going to click this outer wall here, and we're going to go to create name section, and we're just going to do velocity inlet here. And then we're going to do this one all the way here, and this will be our pressure outlet. And our final one of the name selections is going to be everything on the boundary of the wind tunnel. And this will all be under one name as the wall of the wind tunnel. And if we go to our name selections, we can see velocity inlet, the wall, and the pressure outlet. We're going to go back to our mesh. We're going to generate it just to see if anything changed. It didn't. And now we'll go back to the solver where we just were. Alright, so we're going to go in the setup here, and we're going to do double precision for solver processes because that is the max for the CPU. I realized I opened the solution one before. So we'll give it a second to load. Okay, so our setup has now gone, and we're going to just make sure everything we did is good. Viscous is laminar. That's very nice. Material, fluid, air, aluminum. Looks good. And we're going to go to boundary conditions. So this is where the main decision happens. So I will be doing the 20 hertz level of this equation. And with this equation, when we calculate it at 20 hertz, we get 4.6062. However, that is the test section velocity, and we need to give it the inlet velocity in order to get this at the test section. So what we do with this number is we divide it by the ratio, which we've been given just the height of the beginning of the contraction chamber and the beginning of the test section, which is 22 inches and 6 inches respectively. So we times it by the height of the test section and then divide it by the height of the contraction chamber entrance, giving us a ratio, and giving us an answer of 1.256236364, and we're going to just do it exactly how the calculator says. So we're going to apply that, and that is our inlet velocity. Our outlet, we're going to keep it 0. It doesn't tell us to give an outlet pressure, so we're just going to keep that the same. And everything else should be good to go. We're going to go to report definitions, nothing to report. If we go to residuals, we're going to increase these by 0.1 just so it can converge a little more. That shouldn't cause any issues, but everything else should be good. Before we start though, we're going to go to hold on. We're going to go to surfaces, and we're going to go new, and we're going to go line rate. And we're going to create our center line in order to write our data after the test. So what's easy about this is our y is going to say 0, and as we did last time, negative 46.5 and 46.5. As the center of our entire structure is 0, 0, we know the length is 93 from those points. So it's very easy. It's very simple to create. So we're going to do that, and that will be good to go. And now we're going to initialize our thing. All right, and then we're going to go to run calculation, and we're going to do 200 iterations. That's what I did last time, and we will see. Yeah, we'll do 200 iterations. Actually, we'll do 100. Yeah, we're going to do 20 iterations, or 100 iterations only. And we'll let that run for a second. Alright, cool. So we got calculation complete, and it tells us to up until the export of fluent data. So what we're going to show first is the contours. So I'm just going to stay in here to show the contours. We want to show the velocity, static pressure, total pressure, and dynamic pressure, which is very easy. We can do velocity, velocity magnitude. We've got everything here, good to go. We're going to save and display. I need to pick these things as well. And as you can see, that's our velocity. It starts slow, goes high, and decreases gradually through the diffuser. We got a little bit of a issue here, but that's with the cell and the mesh, but mostly it looks correct. And we're going to go to the pressure. We're going to do static pressure, and this should be, it should be the opposite, high pressure here. Let me move this out of the way. You can see the legend. High pressure, low pressure, high pressure here, because the static pressure is inverse relationship of the velocity. Now the dynamic pressure is going to be very similar to the velocity because it is based off of the velocity. And as you can see, low, high, low. And then we're going to go to the final thing, which is total pressure. And this is going to hopefully be constant. And there's some little issues here near the boundary due to some boundary layer. But for the most part, it looks good and A-OK. And that's it for the contours. And what I will do here is do the Fluent Data Excel export. And what we do here is we go to XY plot. And we have this stuff here. We keep this in the X direction because we want it to increase in that way. And we click center line. And we're just going to do this for every single one. So we're going to do velocity, center line, 20 hertz. I'm just going to copy that. So we're going to velocity, velocity magnitude, sounds good. And we can actually show it here, which is very nice. And then we're going to write to file here. And we don't need that. And let me just see where to save this. We're going to go to documents. We're going to go to here. And we're just going to go velocity center line to 2.0. Nice. And then we will do the same thing for our pressures. So we're going to do static pressure, which is here. And we're going to do static pressure. Copy and paste that. Write the file right there. And again, 2.0. Very nice. And then we're going to go to dynamic pressure. write the file, boom, 2.0. And then finally, total pressure, and yep, that's it. Total pressure. Put that there, and there we go. So there you have it. We can actually, just in case we need this, I'm going to plot all of these. And you can tell that the trend is very similar. This is not the right distance, as you can tell if I go back here and make this, the Y is very close, but if you expand this out in pressure, the difference is very negligible and almost constant. I realize I didn't create these separately, so we'll just walk through them. So that's that. Dynamic pressure decreases, increases, just like the velocity. And then finally, not density, static pressure, which is the exact opposite. So there you have it. We went through the design of it, the meshing of it, the setup process. We went through the contours and how to plot the variations and how to export them to Excel. Thank you very much, and I hope you have a wonderful day.